about capacitor. Same case for capacitor. Step number one will make the diagram. Will make the diagram. What in the case of diagram? In the case of diagram, we'll write step one. In step like apply. Yes, E is equal to E naught sine omega t. Apply is equal to E naught sine omega t. That means you have a circuit. In that circuit, you have capacitor. Okay. Yes, this will be our first step. Then our step number two. In your second step, you will find current using E. Find I using E. See, we have formula. We have formula quick climbing valley. We studied in chapter 2, Q is equal to CV, quick climbing valley. In this chapter, in place of V, we can use E. So I am writing my own notation, that is Q is equal to C into E. Yes, you can write V also, no problem. What is current? What is Q? What is Q? What about charge? See, current is charge per unit time. So charge will be, yes, current into time. So I dt will be equal to C into E. What is I? What is I? And what is CE? What is I? I will be I naught sine omega t. I will be I naught sine omega t, and E will be E naught sine omega t. Just a minute. Yes. Sorry, yes, I'll simplify it more for you people. See, we will write Q is equal to CE. Yes, in place of E, what you can write in place of E, you can write E naught sine omega t. I'm simplifying this part for you. So, what about charge? Charges. What about charge? What about current? What is current? Current is charge per unit time, right? If you will differentiate this part, you will get current. So current will be equal to C into E naught will be constant. Sine omega t derivative will be cos omega t, and the derivative of omega t will be omega. So this will be equal to what? This will be equal to C into E naught into omega into cos omega t. Your current value will be equal to what? It will be C into E naught into omega into cos omega t. So what about cos omega t? We can't find the relation for cos omega t and sin omega t. So yes, we will convert like previous one. We will write C into E naught into omega into. What about cos omega t? Sin 90 minus theta is cos theta. But here we will use sin theta minus 90. Yeah, we can use that also. Sin 90 plus theta is also cos theta. So you will do sin 90 plus theta, or you can write theta plus 90, no issue there, because the both will be same, plus sign is there. Sin 90 plus theta is also cos theta, and sin theta plus 90 is also cos theta. Now you can easily compare the relation between them. Now anyone can tell what will be the phase relation, what can be the phasor diagram, what will be the phasor diagram, and what about the graph? Yes, so step 3. Step 3, E is equal to E naught sine omega t. Then we have current. After that, yes. Step 3. In our step number 3, we are finding the 3 things. First will be phase relation. What about the phase relation? Phase relation will be C E is equal to E naught sine omega t, and current will be C E naught omega sine 90 plus theta. That means current will lead EMF by angle how much? By angle 90 degree. So here you will write current leads EMF by 90 degree. Or you can write that your EMF lags current by pi by 2. This was our phase relation. Then what about the phasor diagram? What about the phasor diagram? Let's see the phasor diagram. What about the phasor diagram? Yes, two lines will be fixed for phasor diagram. Our current, that current have same position. Which position current will be? Yes, I am marking it with black one. Yes, current will always be in this position. This is current, and current is leading by how much? 90 degree. We are always going in, we are always going in anti-clockwise direction. That means your EMF will be somewhere here. Your EMF will be somewhere here. This will be your EMF. Angle between E and I will be 90 degree. Okay, so here your EMF lags the current by 90 degree. It will show like this. Now next one, we have phase relation, we have phasor diagram. Then what is the next one? Next is our graph. How about the graph? If I draw a rough graph, see, your EMF will always be in the same direction. Your EMF will be this only. It will be like this. Your EMF will be like this. What about current? current will Current is leading means it will start first and it will end first. It will start first and it will be end first. This red color represents current, and this blue current represents our EMF. This is how your graph will look. Okay, now what about the villain? In this case, the villain will be same. It will come into picture by this equation. This equation is I is equal to C E naught omega sine 90 plus theta. That means what? We have I is equal to I naught sine 90 plus theta. That means this will be your I naught. This will be your I naught. So I naught will be equal to C E naught into omega. If you check I naught, what will be I naught? I naught will be equal to C E naught omega. We will use this for finding the villain. Yes, the next step number 4 will be villain. In this case, the villain will be capacitance. First one was resistance, second one was inductance, third will be capacitance. So that capacitance, how that will comes into the picture? Yes, it will comes into picture by E naught upon I naught. So here in this case, if you check what will be E naught upon I naught, your E naught upon I naught will be equal to 1 upon omega C. And this E naught upon I naught will be termed as XC, capacitive reactance. Previously it was capacitive inductance, now it is known as capacitive reactance. This is how that villains comes into the picture, E naught upon I naught. Okay, so what is omega? Omega will be equal to 1 upon 2 pi FL, 1 upon 2 pi FC, sorry, C. 2 constant, pi constant, C constant. That means your XC will be inversely proportional to frequency. Now you can easily plot the graph of villain versus frequency. Yes, what about villain versus frequency graph? Step 5, villain versus frequency. Villain versus frequency. So if you check villain versus frequency, this is your XC and this is your frequency. It is inversely proportional. That means if frequency is increasing, your capacitance will decrease. So here you will make your graph like this. This was your step number 5. Now the last one, this last one will be same as the previous one. You will get the power value as 0. So let's see the last one. In the last case, you have to find power. So power is equal to what? Power is equal to V into I. V into I means E into I. What is E in this case? E will be E naught sine omega t. And what is I in this case? I will be equal to I naught sine omega t. And what in the case of capacitor? In the case of capacitor, we have plus pi by 2. So this will be equal to E naught I naught sine omega t. Sine 90 plus theta is cos theta. If you speak about the average power, this will be equal to integration of p dt upon integration of dt, 0 to t, 0 to t. So therefore, if you check this thing, so you will get average power as integration of 0 to t. So here, if you check, you will get average power as integration of 0 to t e naught I naught sine omega t into cos omega t upon integration of dt from 0 to t. This e naught I naught will be our constant, and that will go out of the picture, and you will get integration of sine omega t into cos omega t, and sine omega t cos omega t integration will be 0. So you will get the value of average power as 0. This is the conclusion that only resistor consumes power. Capacitor and inductance does not consume power. This can be asked in your MCQs. Okay, now let's see here in this case our power was 0. Now let's some questions based on these topics which we have studied. The first one was resistor. The first question, what is the primary difference between AC and DC? The options are AC changes periodically while DC flows in one direction. B, AC and DC both changes periodically. No. AC and DC both flow in one direction. No. None of these. No. Yes. So option number A. AC changes periodically while DC flows in one direction. Next one. Find the circuit RMS current value when 50 ohm resistor is placed across an AC source with 200 volt and 50 hertz voltage. See what we have in this question. In this question, we have resistor R. What we have voltage V, and we have frequency. We have to find current. So current will be equal to what? Current will be equal to V upon R, because V is equal to IR. What is V? 200. What is R? 50. So 0 0 cancel, 5 1s are 5 4s are. So your answer will be what? Your answer will be 4A, option number A. Next. Yes. The next one is, in an AC circuit, what is the role of amplitude? Amplitude means what? Amplitude means maximum value, not average, no minimum, no frequency. It will show maximum value. Amplitude word itself shows the maximum value, peak value. What does RMS stands for? I think I don't have to give you the option. What is the meaning of RMS? RMS is random mean square. No, it is root mean square. Option A. Then next question. Yes, the question is, if instantaneous current value of current is 8 sine 314t, what is the root mean square value? We have to find root mean square. This is the instantaneous current value. That means I is equal to I naught sine omega t. I naught, this is omega. So we have to find root mean square. So your root mean square will be equal to I naught upon root 2. What is I naught? 8. What is down? We have root 2. 8 can be written as root 2 into root 2 into root 2 into root 2. Root 2, 2 multiply by so what you can write, yes, more terms we have. This is 2, this is 2, multiply by 2. So this will get cancelled, and you will get 2 2s are 4 and root 2. That means your option number D is the right answer. Okay, next. Next, if you check, you have AC voltage applied to inductor. What is the case? What in the case of inductor? In the case of inductor, we have the question that the phase difference between V and I in AC circuit that is entirely inductive is, what will be the phase difference? If you check the phase difference, what about V and I? I will be here, E will be, in the case of inductor, it will be like this. That means how much phase difference will be there? Phase difference will be of 90 degree. Option C. Similarly for capacitor. But in the case of capacitor, in the case of capacitor, this question was asked in year 2023 for 1 marks. The question is, in AC voltage, V is equal to V naught sine omega t, R is a resistor and element is X. The instantaneous current is given I naught sine omega t plus pi by 4. Then which of the following is correct? See, if it is pi by 2, sorry, pi by 4 plus 90. This is the case of plus, na? This is the case of plus. That means that is a capacitive circuit. If that is a capacitive circuit and resistor is R, if that is a capacitive circuit, that means this two option will go out of the picture. What you will use here, you will use formula. Your resistor is what? Your resistor is R, so your option will be option D. Okay. Yes. In AC circuit, if frequency is increased, what happened to capacitive reactance? Right, just now we studied about the capacitor one. X is inversely proportional to frequency. If frequency is increased, this will be decreased. Option B.